Hi students, in this class we are going to see about very important topic in algebra. Yes, of course, Euler's theorem. Many difficult problems can be solved using this theorem very easily. I hope you will follow me nearly up to the end of this class. Okay, let's start. First I would like to explain the statement of the theorem. And I wish to solve some problems using this theorem. So, the statement of Euler's theorem is if n is any integer and the GCD of a and n is 1, then a to the power pi of n concurrent 1 mod n, where pi of n already we know that pi of n is the number of non-negative integer less than n that are relatively prime to n. Okay, now we will go for problem. The first one is find the unit place of 13 to the power 1001. Here we find the unit place of 13 power 1001 mod 10, because the question is find the unit place. So we use the mod 10. Here we check the GCD of 13 and 10 is 1. It's clear? Okay. Here n is 10. So the GCD of a and n is 1. So we apply Euler's theorem to solve this problem. Here pi of n is, here n is 10. So pi of n is equals to 4, because the 10 is relatively prime to 1 and 3, 7 and 9 also. So pi of n is 4. So we divide 1001 by 4. So we get 250 as the quotient. So 1001 is represented as 250 into 4 plus 1. 1 is the remainder. So 13 power 1001 can be written as 250 into 4 plus 1. Okay. Now 13 power 250 into 4 can be expressed as 13 power 4 the whole power 250 into 13 power 1 mod 10. So here 13 power 4 mod 10 is 1, because a to the theorem of the Euler's theorem, the statement of the Euler's theorem is a to the power pi of n concurrent 1 mod n. Here n is 10 and pi of n is 4. So 13 power 4 mod 10 is 1. So we have 1 into 13 mod 10. So 13 mod 10 is 3 mod 10. So the unit place is 3. Okay. Here I have one more problem for you. Find the last digit of, that is the unit digit of, find the last digit of 15 power 55 power 5. Can you guess any answer? Okay, let me tell you the answer. To find 55 power 5 mod 10, because the question is the last digit, that is unit place. Okay, here the GCD of 55 and 10 is not equals to 1. So 55 and 10 is not relatively prime. So the 55 is expressed as 5 into 11. So 55 power 5 is 5 into 11 to the power 5. Now we check the GCD of 11 and mod 10. That is, the GCD of 11 and 10 is 1. So the 11 and 10 are relatively prime. So the 55 power 5 mod 10 can be expressed 5 into 11 to the power 5 mod 10. Okay, which is equals to 5 power 5 into 11 power 5. The 11 power 5 is expressed as 11 into 11 power 4 mod 10. Okay, so here 11 power 4 mod 10 is 1, because 10 and 11 are relatively prime and pi of n is 4. So by Euler theorem, a to the power pi of n concurrent 1 mod n. Okay, so we have, which is equals to 5 power 5 into 11 mod 10. 5 power 5 into 11, 5 power 5 into 11 mod 10, which is concurrent to 5 power 5 is 3125, and to multiply by 11, the answer is 34,375 mod 10. Okay, the last digit is 5. So here mod is 10. So which is concurrent to the remainder is 5. Okay, 5 mod 10. So the last digit is the last digit of 55 power 5 mod 10 is 5. Okay, clear? Next, here is an different problem. Find 3 power 202 mod 13. Find 3 power 202 mod 13. Okay. In this problem, here n equals to 3 power, the problem is 3 power, the problem is 3 power 202 mod 13. Here n equals to 13 and pi of n is, here n is prime, so the formula of pi of n equals to n minus 1, that is n minus 1 is 13 minus 1, 12. Okay, so 3 power 202 mod 13 is represented as 3 power 2 12 into, because here pi of n is 12, so divided by 202, divided 202 by 12, so we get 202 divided by 12, so we get 82, I think 6, 72, remainder is 10. Okay, so 3 power 202, what is the quotient? 16. So 12 into 16, the remainder is 10. So 10 mod 13. So which is equals to 3 power 12 the whole power 16 into 3 power 10 mod 13. So which is concurrent to 3 power 12 mod 13 is 1. So 1 power 16 is again 1. So 1 into 3 power 10 mod 13. Here 3 power 10 is 10 is less than, here 10 is less than 13. Okay, here 10 is less than 13. So pi of n is 10 and n is 13. So we must represent 3 power 10 as 3 cube into 3 cube into 3 cube into 3 mod 13. So we know that 3 power 13 mod 3 power 3 mod 13 is 1, because 3 power 3 is 27. So 27 mod 13 is, remainder is 1. So 3 power 3 mod 13 is 1. So 1 into 1 into 1 into 3 mod 13. So which is equals to 3. So the answer is 3. Okay, thank you. We will meet in next class. Okay, bye.